Hey everyone, and welcome back to Cracking the GRE Math Subject Test. This is Calculus 2, and we are on question number 22. In this question, we're given a function, f of xy equals x cubed plus y cubed minus 3xy, and we're told that it has a local minimum at exactly one point P. And then we want to know what the value of f is at that point. So in order to find the local minimum, we're going to have to find the critical points of f, and I'll just remind you that the critical points are the points where fx is equal to 0 and fy is also equal to 0. In other words, where the gradient is equal to 0. So fx is equal to 3x squared minus 3y, and fy, and this has to equal 0, and fy is equal to 3y squared minus 3x, and this also has to equal 0. Now, let's see, if we divide by 3, we'll get x squared equals y, and here we'll get y squared equals x. Well, if we plug in, if we substitute y equals x squared here, that'll give us x squared squared, so that'll be x to the fourth equals x, or x to the fourth minus x equals 0. If we factor, we'll get x times x cubed minus 1 equals 0, which means that x is equal to 0 or x is equal to 1. And if x is equal to 0, then y also has to equal 0, and if x is equal to 1, then y has to equal 1. So we found two critical points, 0, 0, and 1, 1, and we have to decide which of them is a local minimum. So in order to do that, we need to use the Hessian matrix. I'll just remind you that the Hessian is the matrix fxx, fxy, fxy, fyy. And if we take the determinant of this matrix, then, and it comes out negative, then we're and we evaluate this determinant at a certain point. Then, and if it's negative, then we have a saddle point, and if it's positive, then we have to check. If fxx is also positive, then we have a local minimum. So, let's see, what is this determinant going to be? Well, fxx is going to be the derivative of 3x squared minus 3y with respect to x. That's 6x. fxy is going to be the derivative of this same fx with respect to y, so that's going to be negative 3. fyx or fxy is going to be the same thing, negative 3. And the derivative of fy with respect to y is going to be 6y. So our determinant is going to be 36xy minus negative 3 times negative 3 is 9. Alright, so now we can check. If we plug in 0, if we evaluate this at the point 0, 0, we'll get negative 9, which is a saddle point. And since we know there's exactly one local minimum, that means that 1, 1 has to be our local minimum. We can check that too. We can plug in 36 times 1 times 1, that's 36, minus 9 is going to give us 27, which is positive. So we know that this is either a local max or a local min. And if we plug in 1, 1 to the second derivative of x, which is 6x, yeah, 6x, that's positive, so we get, so we know that we're talking about a local minimum. Alright, so now we just have to plug this into the original function to figure out what the value of f is at that point. So f of 1, 1 is going to be 1 cubed plus 1 cubed minus 3 times 1 times 1, which is 2 minus 3, or negative 1, That is answer D.